Then let's move on some examples for horizontal channel dynamics. What are the advances? As I mentioned, that with these tools, we are not restricted only to like cross-section surveys that in a traditional way, but maybe many of you have already seen similar things. You can have high-resolution point clouds even from another view survey of a riverbank, and then we can densify the already existing cross-sectional data, and it can serve as an accurate tool for this. And also, if we would like to monitor the riverbank erosion processes with the appropriate georeferencing, we can reveal changes. If we map complete subreaches, especially in the barely vegetated conditions, we can even find some additional features like the paleo channels and the tributaries, and how they modify the bank erosion process when they have an intensive flood event, and so on. Of course, they serve as a monitoring tool, which is not always possible or in a cheap way from the traditional remote sensing technologies. And yeah, sorry, it was already shown. And these are some of the examples. Also, it happened a few years ago that the drones can serve as a rapid tool. It was a so-called crevasse pay event, where in an increased flood, in even a 4 peak of flood event caused an extensive bank erosion at this outer bank. The flow direction is coming from here, and it collapsed this outer bank. And we help the local authorities to calculate how much sediment has been deposited and to reveal why it happened exactly. So these are also an advantage. And if we would like to understand what are the most dangerous sections of these kind of rivers, if the rate of bank erosion, like in this case, you can reveal that in 5 years, it's like 40 meters of change in these selected meanders in Hungary, the Solyó River. Even a not that accurate georeferencing is enough when we can monitor like 3 or 4 meters per year rate. But there are some cases when the river doesn't shift too much, or we would like to reveal some change detection on the vertical changes of our point bar surfaces. We have to be more precise on the georeferencing. And yeah, as I mentioned, the vertical channel dynamics. So what is another advantage besides just a simple change detection, a surface change detection, is the granulometry, which was basically relying on some deterministic and statistical approaches to estimate grain sizes more easily than collect the samples and then sew it and then define the grain curves. This new advancement also in the computer vision and object-based image analysis can easily determine the geometrical features of this, and it can be well validated by the UAS data. I mean, the UAV data can be well validated. And now the recent advancements, as the inclusion of machine learning and convolutional neural networks, we can not just rely on stationary hovering and like selecting several small like samples. We can even extend it into a whole subreach, and we can, based on these learning algorithms, we can highlight the spatial distribution and the spatial characteristics of the sediment load and the sediment depositions that can help a lot for preventing the extreme events. As a general recommendations, of course, high resolution imagery with low signal noise ratio and chromatic aberration. We need better cameras. And of course, the Nadir camera should have a lot of stabilization. The RTK drones also help a lot with their own base stations. They can provide even the centimeter accuracy or maximum centimeter deviation in the positioning. And of course, when the light is changing, they can give false results in terms of the colors with these grains when if we do even a 1 minute survey on that. And there are some periods when the light conditions can change abruptly. In that case, it's not so suitable. And then as a last direction from my talk is about channel bathymetry, because the drones, as I mentioned, they provide a lot of details, high resolution details on the river channels in the morphological point of view, but we are really interested to look under the water, because, for example, the bank erosion processes are also driven by the hydraulic conditions below the water. We have several methods available in this technology, the radiometric methods and the geometric methods. The radiometric methods even include multispectral surveys, and that combination can help us to derive those water depth values. And yeah, I pointed out several methodological concepts, how it relies on the attenuation of light with increasing water. And these also opens new insights in specific conditions, of course, but it's not working on really deep and turbid water. So we have to take care about these methods as well. The passive geometric methods are based on this so-called Snell's law. When the light is refracted on the surface of the water, and when it passes through, it's finish or yeah, it ends in a different position. And when we can support this with photogrammetry, and the photogrammetry can help us to model the refraction. If we know some kind of uniform refraction value as the water, we can check where was the known camera pose and the surface location, and then we can model the depth point of under the water. Of course, in this case, the salinity and even the temperature influence the refraction index as well. So we don't always have a uniform refraction index. Maybe we can also calibrate the method to the local sites. We need calm water surface, because for the method we estimate a flat water surface, which we know it's not existing in these rivers. So as much as calm as the water, the surface, the bathymetric reconstruction will be also better. And in the geometric way, based on imagery, we have to see the riverbed for the texture, for the image point matching. So if we increase the turbidity and increase the sediment load, it will cause increased uncertainty. But in smaller river reaches, in smaller meandering rivers, and in smaller braided rivers, it can be a nice tool that cannot be done in this resolution by the traditional survey methods. Of course, it can be done by LiDAR, but of course, it's more expensive. One example how high resolution is that from one of our recent study have been published in several river types and conditions. The left one, we can say the Freiberg and Mulder River in Germany, which is a more gravel bed river with much more say turbulence on the water surface. Therefore, the bathymetric reconstruction was not performed well. So this is the limitation. But when, for example, in these two other rivers, the Shire River in Hungary and the Purmonkey in Finland, especially in the Purmonkey, we have a shallow water and clear water stream with not increased sediment load. It's almost a smooth bathymetric reconstruction has been done. And here in the Shire River, in the outer banks, when the helicoidal flows appear, and also these parts are the deepest points of the river channel. Of course, it also has some blank parts from the reconstruction. But if you can think that these are a really high resolution data set can be easily applied for modeling. It is a really useful tool. And as the last part, the active geometric methods based on the bathymetric laser scanning, as we use the green glider that use simultaneous measurement of the water surface and the under points possible. Of course, it also has some limitations, but performs more well. But of course, the prices are much higher. And I'm talking about UAS, so we don't have the green lidar yet for the drones, but soon in the future it will also hopefully can be done. I didn't put a whole conclusion slide, but as you can see, the drones are providing high resolution data sets directly, and in our vision, the future will be, as I mentioned, like even the grain size analysis will be supported by these machine learning and the deep learning methods can be done live directly at the site. We don't have to wait for the post-processing. If we have enough training data, especially when we would like to do repeated flights at the same site, we can like stream out the grain size distribution and grain size changes after a flood event. So these in recent changes in the river channel dynamics, I wanted to highlight a few directions and through applications. So thank you for your attention, and if you have questions, and feel free to ask. Thank you.